Hello everyone, welcome back to our channel Alchemist. Today we are going to see the chemical bonding. Let's get into the video. And now we are going to see the general introduction to chemical bonding. Okay. As we all know, there is a bond between you and your mother and your sister and your father. Okay. That bond is within the family. Okay. In chemistry too, the atoms combine with another atoms through a bond. Okay. That bond is known as chemical bonding. Okay. They are chemically bonded together. And in this video, we are going to see the types of bonding and all those steps. Okay. Let's see it one by one. Okay, first we are going to see the types of bond. Okay, there are three types of bonding. Okay, that is ionic bond, and then covalent bond, and then coordinate bond. Okay, let's see it one by one in detail. And now let's see the first type of bond, that is ionic bond. Okay, going to ionic bond, you have to recall what we saw in the previous lectures, that a noble gases family, that is electronic configuration of noble gases. Okay, as we all know, noble gases family have the stable electronic configuration. Okay, and other elements also want to achieve this noble gas configuration either by losing or gaining electrons. Okay, this is a basic thing you have to know while studying the ionic bond. And now let's see the definition for ionic bond. Ionic bond means a transfer of electrons from one element to another element. Note that important word is a transfer of electrons. And then ionic bond is otherwise known as electrovalent compound or electrovalent. And then in ionic compound, the force of attraction is electrostatic force of attraction. It is very strong force. Okay. Okay. Let's see the example for ionic bond or ionic compound. Okay. NaCl is the best example. As we all know, sodium has an outermost electronic configuration of 2, 8, 1. Okay. One electron is in the outermost shell, and in chlorine 2, 8, 7. Okay, it needs one electron. Okay, so it borrows from sodium and become an octet structure. Okay, sodium also becomes 2, 8, and chlorine becomes 2, 8, 8. Okay, Na plus and Cl minus. Sodium lose one electrons to become an octet, and chlorine gains one electron to become octet. Now they two are both stable electronic configuration. They attain the noble gas electronic configuration. So this compound is the best example for ionic bond. Okay, they form a bond, that is NaCl. The bond is ionic bond, and the force of attraction is electrostatic force of attraction. It is very strong. Okay, that bond force is very strong. And then notes for ionic compound. As we all know, ionic compound is or otherwise known as electrovalent ionic compound, or otherwise known as electrovalent compound. And then the main important word, as we saw in the previous slide, that is transfer of electrons from one element to another element. Okay, and then the force of attraction is electrostatic force of attraction. It is very strong. Now we are going to see the conditions for forming an ionic bond. There are three conditions, okay, while forming an ionic bond. Let's see it one by one. The first one is the ionization potential. Ionization potential means the amount of energy required to remove the most loosely bound electrons. The definition, okay? And we know for forming an ionic bond, there will be a transfer of electrons, okay? So, one atom will have a high ionization potential and the another one have a low ionization potential, okay? As we know, the trends in periodic table, that is on moving from left to right in a period, the ionization potential will increase. Okay, and then from moving from top to bottom in a group, the ionization potential will decreases. Okay, this is the basic trends we know, and this is one of the condition for forming an ionic bond. And then the next one is the electron affinity. Electron affinity means the energy released. Okay, and in this also one atom have a high electron affinity and the other one have a low electron affinity value, and the trends is also same as that of ionization potential. And the third one is the electronegativity. The electronegativity means the tendency to attract the shared pair of electron towards itself. It's a definition. And in this too, one atom must have a low electronegativity value and the other one have a high electronegativity value. So the difference is very large. Okay. Only in this condition the ionic bond will be formed. And then the metals in group 1, 2 and 13 and non-metals in group 15, 16 and 17 will form an ionic bond. Okay, only in that group. Okay, from the conditions we saw in the previous slide, that is in metals group there will be a low ionization potential, low electronegativity and low electron affinity value. Okay, and the metals and non-metals they transfer the electrons and form ionic bonds. Okay, let's see example. As we already saw, the NaCl is the example in the previous slide. In this slide we are going to see the magnesium chloride. Okay, and magnesium is in group 2 and this satisfies the metal, and chlorine is in non-metal, that is group 17. Okay, and magnesium has low ionization potential, low electron affinity, low electronegativity, and then chlorine has high ionization potential, high electron affinity and high electronegativity value. Okay, let's see how ionic bond will form. Magnesium has an outer valence electrons of 2, 8, 2 and chlorine has 2, 8, 7. Okay, magnesium gives one electron to this chlorine and gives one electron to this chlorine, and magnesium become an 2, 8, that is a stable electronic configuration, and Mg2 plus and Cl minus. Okay, it also become Cl minus, it is also an octet configuration, and it also become a Cl minus, it becomes an octet. Okay, the bond formed between these two is the ionic bond. Okay, and then the next one is the calcium oxide. Calcium is in group 2 and then oxygen is the non-metals. Okay, and they transfer the electrons to form an ionic bond. Okay, the bond between calcium and oxygen is ionic in nature. That is, the outermost electronic configuration of calcium is 2, 8, 8, 2. Okay, and oxygen is 2, 6. Okay, oxygen needs 2 more electrons to become an octet. So calcium gives its outermost 2 electrons to oxygen. So it becomes Ca2 plus and O2 minus. Okay, the bond between the two is the ionic bond. This is the examples for ionic compounds. Let's see what is covalent bond. Okay, this is the best example to illustrate the covalent bond. When we put the ball and bat separately, it will not useful. Okay, we use it. We use both and we play. Okay, when bat will not accept the ball or ball will not accept the bat, it will not useful. Okay, sharing is the important word in covalent bond. Okay, sharing takes place. This is the best example, H2 molecule. Hydrogen atom has one electron and another hydrogen atom has one electron. These two atoms form a bond that is covalent bond. They share one electron. One hydrogen atom share one electron and another hydrogen atom share one electron. They share electron and as a result a bond will be formed. That bond is covalent bond. Covalent bond means sharing of electrons and intermolecular force of attraction will be present in covalent bonding. And now we are going to see as we already know, it's formed as a result of sharing of electrons. And now we are going to see the example. As we already saw hydrogen. Hydrogen is the bond between H and H is a covalent because it shares an electrons. Hydrogen has one electron and another hydrogen has one electron. They share to form covalent bond. And in oxygen too, they share, okay, they share electrons. Like oxygen has a 2,6 electronic configuration, so it needs 2 electron and double covalent bond, and in nitrogen has triple covalent bond. Okay, 4 electrons shared between 2 atoms. Okay, in this 2 electrons will be shared, in this 4 electron will be shared, in this 6 electrons will be shared. Okay, it's a triple covalent bond. And in this also the conditions required. Okay, let's see the conditions. And in this both the atom have high ionization potential. Okay, so N2O2 H2 Cl2 molecules are the examples for covalent compounds because they have high ionization potential, and both the atom have high electron affinity value too. And then the electronegativity difference between the two atoms is 0 because the two have the same electronegativity value. Okay, nearly equal, so it is 0. And then in covalent bond there are two types, that is polar covalent bond and non-polar covalent bond. Let us see them in. Okay, now we are going to see the polar covalent bond. Polar covalent bond means, as we already know, covalent bond means sharing of electrons takes place. In this polar covalent bond also sharing of electrons takes place. But they are not at equal distance. The two atoms are not at equal distance. Okay. And there's a charge separation takes place. Some charges present in it, and the charges, the responsibility for the charges is the electronegativity values. Okay. And let's see the example. HF is a polar covalent bond. Okay. As we all know, hydrogen has 1 electron and fluorine has 7 electron in its valence shell. They share electron to become a polar covalent bond, and in this, as we all know, fluorine is the most electronegative element when compared to hydrogen. So, there is a partial negative charge present in fluorine atom, and hydrogen atom contains a partial positive charge. Okay, there is a charge, some of the charges present in it, so they are not at the equal position. Fluorine has high electronegativity, so the bond tends in the fluorine side. More will be in the fluorine side. And then the next example is water. Water is a polar covalent bond. As we already know, oxygen has an outer electronic configuration of 2,6. It needs 2 electrons to become an octet. So, two hydrogen will combine to form oxygen and octet. Okay, oxygen become a 2,8, that is a noble gas configuration, and hydrogen become a doublet structure. So, H2O is a polar covalent bond. Okay, in this oxygen has a high electronegative value, so it becomes a partial negative charge. Okay, delta minus, and the two hydrogen becomes a partial positive charge, delta plus. So it is a polar covalent bond. And then the next one is non-polar covalent bond. Non-polar covalent bond means they do not have electronegativity differences, and they are at the equal distance. Okay. Examples are, as we already see, H hydrogen. It has a non-polar covalent bond or simply covalent bond. Okay. They share electrons. Okay. Sharing only happens in this. It's a question time. Okay. Is CCl4 is a polar or non-polar? This is the structure for CCl4. CCl, Cl, Cl, Cl. As we already know, carbon has 2, 6. Okay. It needs 4 electrons to become an octet. So it combines with chlorine, and as you see here, there's a charge separation. That is Cl has high electronegativity, so it is delta minus, and carbon has delta plus. When we see it, the only molecule, that is CCl, it is polar. Okay, that because there's a charge separation and electronegativity distance. But there are 4 CCl bonds. Okay, they cancel each other due to electronegativity distance. The effect of electronegativity is nullified. Okay, and they are equal and opposite, and hence it is non-polar. Okay, chlorine has greater electronegativity value, and they cancel each other. Okay, and there's a charge separation because of the effect of electronegativity. It is nullified. Overall, the molecule is non-polar. And then characteristics of ionic and covalent compound. Okay, as we all know, solid NaCl, that is salt, we use normal salt, doesn't contain electricity because of strong electrostatic force of attraction. And then when we dissolve the salt in water, in molten state it conducts electricity. Okay, the attraction is lost due to high temperature in solid state. And then dissociation means we dissolve, ionic compound forms ions, and when we dissociate in water or any. Okay. Okay. Polar covalent compounds, when we treat with water, reaction takes place. But non-polar covalent, it is whether it will be a gas or any other liquids. Okay, it will not be solids and no reaction takes place. We will see it in the later slides. Okay, ionization. Ionization means ion formation. As we all know, polar covalent forms ions in aqueous solution. When we dissolve in aqueous means water. Okay. Okay. As a result, ionic and polar covalent bond conduct electricity because they form ions. Non-polar covalent bond, when we react in water, it does not react with water. No reaction takes place. So, ionic and polar covalent compounds only conduct electricity. And then, okay, ionic bond is stronger than covalent bond. As we all know, the force of attraction in ionic bond is electrostatic, and in covalent it is intermolecular force of attraction. And then physical state. Ionic compounds are hot solids. For example, NaCl, it is salt. And then covalent compounds are gases, liquids, or soft solids. Example, oxygen, nitrogen, water, etc. Okay. And now we are going to see the melting and boiling point. For ionic compounds, there will be a high melting and boiling point. Okay. And for covalent compound, low melting and boiling point, because in ionic compounds the force of attraction is electrostatic. It is very strong, and For breaking, we need a very high temperature. Okay, so high melting and boiling point. And for covalent compounds, there is an intermolecular force of attraction, and this force is very low when compared to electrostatic force of attraction. Okay, in this we are going to see the last bond, that is coordinate bond. Okay, first let's see the example. It will be easier to understand what is coordinate bond. Okay, in this, ammonia is given. Ammonia is a covalent compound. Okay, when it reacts with proton, it forms ammonium ion. Okay, in this ammonia there will be a lone pair of electron, and that lone pair of electron will completely share with the hydrogen, that is H plus. Okay, so the bond, okay, it will represent it as an arrow mark. Okay, let's wait, I will put the arrow. That bond is known as coordinate bond. Hydrogen, that bond is known as coordinate bond. And let's see in another example, that is hydronium ion, that is H3O plus. H3O plus hydronium ion. Let's see what happened. In water and a H plus react to form a hydronium ion, and the hydronium ion, there is a coordinate bond present. Okay, there will be a two lone pair of electron. In this, one lone pair of electron react with hydrogen to form a coordinate bond, and another lone pair is still there. Okay, this one is the coordinate bond. Okay. Okay, the bond formed between the two atoms by a pair of electrons. Mostly covalent and coordinate is like sharing, but in covalent compounds, the two atoms will share an electron, but in this coordinate bond, a lone pair of electron will completely share to a proton. Okay, this is known as coordinate bond. If you have any doubts, put it in the comment box. We will surely help you out, and thank you for watching.